So in this session,
Protein from diet.
we should be able to define vitamins. Okay, what are vitamins? We have to classify vitamins based on their solubility. Okay, so based on that, we classify vitamins into two groups. We have to list the recommended dietary allowance, dietary sources, and the coenzyme forms of individual vitamins. This includes A, D, E, K, and all the B complex vitamins as well. Some of you have all the vitamins. Optometry will have to study about all the vitamins. Allied health will study about few. Okay, B complex and vitamin D and A. We are going to study. So some of the classes. So next year, you should be able to explain the biochemical functions of these individual vitamins and describe the disorders. What happens when the concentration of this vitamin increases in the body or decrease? Right. Okay. So as you told me, it is inorganic compound. Okay. Occurs in natural foods. As we have already discussed about this, it has to come from outside, so it should be available naturally. But there are some synthetic forms available which we take nowadays in the form of supplement. But vitamins classically are defined as organic compounds that occur in our natural foods, which are required by our body in minute amounts. Very less amount is required. It's not very heavy as carbohydrates, lipids, proteins, etc. So these go into the category of micronutrients, which is very useful for normal growth, maintenance, and reproduction. So basically, normal functioning of the body. For that reason, we require vitamins. So how do we define a vitamin? It is an organic compound which occurs in natural food, required to our body in minute amounts for natural growth, normal growth, maintenance, and reproduction. Okay, so that is how we define a vitamin. So to classify, we classify vitamins into two classes based on their solubility. Okay, so some vitamins are soluble in fat, some are soluble in water. So this image gives us a broader perspective of seeing how vitamins are classified. So first broad classification is between fat soluble and water soluble vitamins. So we have vitamin A, D, E, and K that are soluble in fat, and B complex and vitamin C soluble in water. Okay, so B complex has two more categories that we are not focusing on. We'll focus this all of these things together. We have B1, B2, B3, B6, B7, B5, B9, and B12. So far, B4 and B8 are not identified. Okay, it is there. It is not being identified. Maybe in the future classes, maybe next year or for MLTs, maybe next year you might study B8 or B4. It is possible, but right now these are the vitamins that are present. So here, what you are supposed to know. Okay, here you have to know the first broad classification. Okay, fat soluble and water soluble vitamins. Why they are fat soluble and why they are water soluble? It's very simple. Okay, water soluble vitamins means these vitamins can easily dissolve in water. Okay, very simple. Fat soluble, they require either oils or other organic solvents to dissolve. In our body, there are no other organic solvents except oils, fats. So these are fat soluble vitamins. So when you take this in our diet, they are mostly accompanied either by a animal product or fat. Okay, we rarely get fat soluble vitamins from plants, as the primary source of fat soluble vitamins are animal sources. Unlike this, here it is both. So can you tell me one good source of vitamin C? Water. Okay. So one of the biggest vitamins we'll start with vitamin A. It is a fat soluble vitamin, as we already seen. It is found only in food of animal origin, except one, which is a vitamin of vitamin A called carotene. Okay, so except that vitamin, all other forms are only available in animal origin. We cannot get it through plants. So vegetarians, that's a problem for you. But we'll see. When we see into the sources, we'll come to know which one is what all sources we can take. So these has 4 vitamins. So that brings up the question. First question for the day: what is a vitamin? Okay. So vitamin is chemically similar substance. Okay. Similar to what? Similar to the vitamin itself and has similar activity. Okay. Chemically similar substances and has similar vitamin activity. These substances are called as vitamins. Okay. So vitamin A has 4 vitamins. Number 1 is retinol, which is vitamin A alcohol. Second is retinol, which is vitamin A aldehyde. Third is retinoic acid, which is vitamin A acid. And fourth is beta carotene, are also called as provitamin A. Okay, so only this beta carotene is the one which we get from the plants. All the other 3 vitamins are available only in foods of animal origin. Right. So next is RDA, recommended dietary allowance. So what is this recommended dietary allowance? It is the estimated amount of a nutrient or calories per day required necessary for maintenance of good health. Okay. So it's the estimated amount of nutrient that we have to take to make sure that our good health is maintained every day. Okay, so this big definition is condensed into 3 words, and those 3 words are recommended dietary allowance. So according to uh, how much do we have to take? So adult males among us, we have to take a minimum of 3,500 international units of vitamin A daily. For adult female, it is 2,500 international units, and the requirement varies. Okay, more is recommended for children, those who are pregnant, and lactating mothers. Okay, so adult male should take 3,500 units to maintain the good health, to take all the benefits from vitamin A. Adult female has to take 2,500 international units, and more is required. Sometimes up to 5,000 international units can be prescribed to children, pregnant women, and lactating mothers. So from where can we get vitamin A? So dietary sources are food substances that contain the said nutrient. Okay, in this case it is vitamin. In other cases it can be milk. Okay. Continuing on, dietary sources. We can categorize any dietary source or any food substance into 3 categories broadly. One is rich source. Okay, rich source means it contains quite high amount of that nutrient, which is very good. We have to take. So any food source from that nutrient we can categorize into 3 categories. Okay, based on how much concentration of that nutrient is present in that food. If it is very high, then we can say is the best source. Okay, best source will contain the food materials from has the highest concentration of that nutrient. When it is high, okay, we categorize them into rich sources. When it is little bit less, then it goes into good sources. When there is nothing, okay, or very less amount present, then they go into poor sources. Okay, please understand these 4 categories. Best sources means the foods that contain highest concentration. For example, for calcium, milk is the best source. Okay, because out of all calcium, highest concentration we can find it in milk. Okay, similarly, good source means the ones which contain good amount of calcium concentration. A rich source means it contains that gap between best and good. You understand this slowly. So, but this is the basic categorization of quality of dietary sources when we base the food products in which the concentration of this nutrient is present. Okay, so here we'll focus on rich, best, and good sources. Okay, so animal sources are very good because out of four vitamins, three vitamins will be found in animal source, only one is present in vegetarian or plant sources. So here, liver, kidney, egg yolk, milk, cheese, and butter are best sources. Okay, why best? Because all these food food we have mentioned contains the highest concentration of vitamin A compared to other food materials. Okay, why? Liver oils, fish liver oils, shark liver oil, or cod liver oil will have rich concentration of vitamin A. At the same time, vegetable sources which contains mainly carotenes. We have to take yellow and dark vegetables and fruits for this. Fruits such as mangoes, papayas, and vegetables such as carrots, spinach, pumpkins, etc. Okay, so please understand this. Animal sources are best and rich. Vegetable sources are good. Why? Because in vegetable sources only carotenes are present. Okay, other three vitamins are not available. Compared to each other, we are categorizing these food materials into three categories on how much concentration of these vitamins are present. Okay, so these are the dietary sources. Whenever you are writing in your examination, you have to make sure that you mention the rich and best sources first. Okay, you have to focus on writing about rich and best sources first. Very important. Then go for good sources. Okay, don't have to write all the 50, 60 names. Make sure you have prepared a list of 4 to 5 sources, good sources, and that needs to be mentioned. Okay, initially for rich and best, then go for good source. Here, when you are writing, you have to make sure that whenever you are giving a vegetable source or a plant source, that you specify it contains only carotenes. Okay, it's very important. It tells the person who is evaluating your paper that you know very well or in depth about the topic. Right. So continuing on, biochemical functions. Now here it has 6 very important biochemical functions. So vitamin A is involved in 6 very important functions in our body. Number 1, in vision, in reproduction, in epithelialization or maintenance of epithelial tissue in the body, in bone and teeth formation, growth, and metabolism. Okay, so this is the 6 areas where vitamin A will have its biochemical function. So vitamin A is required for a minimum of these 6 functions in our body. So each function you have to study in little bit detail, not extreme detail, little bit detail you have to study. And one of the most common questions that is being asked regarding vitamin A is how it is involved in vision. Okay. So my question to you is, what is the most common deficiency symptom or condition happens when the vitamin A is less in the body? It is some sort of blindness. Okay, so we have to make sure how, and we have to learn how vitamin A is involved in vision. So that is what we are going to do now. Right. So this mechanism or this cycle involvement of vitamin A in vision was identified and discovered by a person called as George Wald. Okay, so he was awarded the Nobel Prize in 1968 for his discovery. He said events occurring a cyclic process. So he said this whole reaction is a cycle. Okay, it keeps on continuing, and he named this cycle as either rhodopsin cycle or it is named uh, on him itself, Wald's visual cycle. Okay, so here you have to understand it's a cyclic process. It keeps on repeating itself. It keeps on going, continues. So it's not one time deal. Okay, it does not happen once and it will stop. It keeps on going. Right. So we all know that eye possesses rods and cones. Okay, this is the anatomy of the eye. Right. So our eye contains rods and cones, which play a very important role in catching light. Okay, light and color. So each these cones have specific functions. Rods are very important for dim light vision. Okay, if you want to see more at night, then rods play a very important role because they capture or they are functional. They get stimulated when dim light falls on them. At the same time, cones get excited or stimulated when bright light or color light falls on them. Okay, so rods are responsible for vision in dim light. Cones are responsible for vision in bright and color light. So let's understand the basics here. How each rods and cones are responsible. Okay. So here few reactions you have to note. So we'll do this and we'll stop for today's class. We will continue in next class. The reaction happens or starts when a photon gets exposed on the rods or cones both. Okay, so here when the light is exposed or the photon is exposed, there's exposure of photon on the rods and cones. A biochemical reaction happens, that is isomerization, where 11 cis retinal is isomerized to all trans retinol. Okay, 11 cis retinol to all trans retinol. Okay, this reaction happens. You can see here. Okay. So this conversion leads to a conformational change in opsin. Opsin is a chemical compound present in retina, leads to conformational change in opsin, which generates a nerve impulse. Okay, so that nerve impulse is the one which we see. Okay, so anything that is stimulated, it produces a nerve impulse, which we process as image. So that is a uh, uh, basic how vision works, right? So immediately, all trans retinal gets isomerized to 11 cis retinal, and this reaction is catalyzed by the enzyme retinal isomerase. Okay, so why this is important? We'll see. Now this is very important. Once this conversion is over, 11 cis retinal combines with opsin to regenerate rhodopsin. Okay, so conversion of opsin and rhodopsin is very, very important. Otherwise, this cycle will not continue. Okay, so this should happen. So this is the basic one cycle. So what happens? Light falls on the retina, which isomerizes 11 cis retinal to all trans retinal. Okay, so this isomerization leads to conformational change in opsin, which generates the nerve impulse. So this nerve impulse gives us the image. We process it as an image. Now, once that is over, all trans retinal immediately gets isomerized to 11 cis retinal by an enzyme called as retinal isomerase. Very important. Once this isomerization is complete, 11 cis retinal then combines with opsin to generate rhodopsin. Okay, so this opsin to rhodopsin cycle generates vision. So what are the biochemical reactions involved? One is isomerization of 11 cis retinal to all trans retinal. So this completes the visual cycle. That's it. There's one biochemical reaction happening, and interconversion of rhodopsin to opsin continuously goes on, and the image is generated that we visualize. However, the conversion is not complete. The visual cycle is complete. The conversion is not complete. The biochemical reaction is not complete. Now, all the action goes from eye, shifts from eye to liver. Most of all trans-retinal is transported to liver. That means that this all trans-retinal is not getting isomerized to 11-cis retinal. It gets transported to liver where it is converted to all trans retinol by the action of alcohol dehydrogenase enzyme, which is normally present in liver. That product, all trans retinol, then undergoes isomerization to 11-cis retinol, and from there it is oxidized again by the same enzyme to 11-cis retinal. 11-cis retinal goes back into the eye, then participates in the visual cycle. Okay, so this is how it happens. There are two different parts we can say about the opsin-rhodopsin cycle. Number one is the visual part of the cycle. Has only one chemical reaction where isomerization of all trans retinol happens by the action of retinal isomerase, which is very important so that opsin can be generated. Okay, so opsin-rhodopsin cycle generates photon. However, this reaction is not complete. There is still some amount of all trans retinal that is left, which is not isomerized. So this is has a counter effect on the visual cycle. So then it is transported to liver, where first alcohol dehydrogenase acts and converts it into all trans retinol, which is isomerized to 11-cis retinol and then oxidized to 11-cis retinol, which comes back to the eye and participates in the visual cycle, which results to efficient conversion of opsin to rhodopsin. Okay, so with that